tracking an asteroid. And TAG is an acronym that describes our sample collection strategy. We're going to send the spacecraft down for a short duration contact with the asteroid surface, anywhere between 5 and maybe as long as 15 seconds. So we call it a touch and go, or tag an asteroid. Constraints and, of course, our science objectives. And when we looked at the capabilities of our spacecraft, we knew we needed to go to what was called a near-Earth asteroid. So we were basically looking at its orbital properties and its location within the solar system. We needed an object whose orbit was pretty similar to the Earth so that we could launch off of our planet, rendezvous and spend some time at the asteroid, and then leave and bring this precious scientific cargo back to Earth.
You know, in fact, just this past August, a truck-sized asteroid missed the Earth by less than 2,000 miles, and nobody even knew it was headed our way until it already passed us by. So for our survival, it's essential that we understand what's out there in our environment in space. And this is one of the main objectives of the Osiris-Rex mission. We'd like to go out and meet Bennu before something like Bennu comes and meets all of us. So Dante, what can you tell us about this idea of planetary defense?
Over 200 million miles away from Earth, NASA's Osiris-Rex spacecraft is preparing for an ambitious sample collection attempt at asteroid Bennu. Before it makes its approach to the rocky surface, let's take a look back at some of the incredible firsts for this mission, which almost seem like something out of a Hollywood movie. This is the first asteroid sample return mission for NASA, and it could be the largest return from space since the Apollo astronauts brought moon samples back to Earth. While getting set to grab a sample, Osiris-Rex has set not one, but 2 Guinness World Records. Its first for the smallest ever body orbited, and its second for the closest orbit of a spacecraft. This tight orbit has brought the spacecraft so close to Bennu that Osiris-Rex's onboard cameras and laser altimeter have been able to image and characterize the asteroid's surface and shape better than Earth, our own moon, or any other celestial body. Osiris-Rex has imaged Bennu down to 5 cm per pixel resolution, providing us with an unprecedented view into this rocky and boulder-filled world. With 28 onboard thrusters, Osiris-Rex is one of the most maneuverable spacecrafts. This allows it to carefully and precisely descend to a spot on Bennu that is no larger than a few parking spaces. There have certainly been some unexpected twists along the way. However, Osiris-Rex has capitalized on these moments. Right after arriving at the asteroid, Osiris-Rex imaged rocky ejecta that has been bursting off Bennu. This is the first time we have been able to observe the entire life cycle of a natural satellite ejecting off an object, entering into orbit, and returning back to the surface. Because of Bennu's extremely rocky surface, the team needed to adapt the spacecraft's navigation method to an optical approach known as natural feature tracking, or NFT. This is the first time this approach has been used in space, and it will allow Osiris-Rex to steer itself down to collect a sample from Bennu. And now, Osiris-Rex is looking to set another first for NASA. Successfully collect a sample of an asteroid and deliver it to Earth by 2023.
Welcome back. If you're just joining us, I'm Michelle Fowler from NASA's Goddard Space Flight Center, and with me is Dante Loretta from the University of Arizona. And you are here with us on a historic evening. It will be NASA's first sample return from an asteroid. The attempt to actually sample the asteroid Bennu. The spacecraft Osiris-Rex is descending toward Bennu right now to take a sample and return it back to Earth. So Dante, let's talk more about this real-time simulation that we're looking at.
Yeah, it's been an exciting day already, Michelle. We're well over 3 hours into the TAG sequence, which is the pre-programmed set of commands that are already on the spacecraft. Earlier, we departed our orbit around the asteroid, so we're flying over the sunlit side of the asteroid, taking images for the onboard guidance system called natural feature tracking. A couple other key events that have taken place already is the spacecraft has deployed its robotic TAG-SAM sampling arm, so the arm is ready, in position to collect that sample. And we've turned on and started collecting science data from one of our science instruments, the Otis thermal emission spectrometer. The spacecraft has already moved into its second natural feature tracking attitude and is getting onboard positional updates as we speak. And I can tell you, everything is going exactly according to plan right now. It looks really good.
Oh, it's been an exciting day. So Osiris-Rex has traveled more than 2.5 years as it navigated its way to this delicate orbit around Bennu. And once there, it began mapping the surface, one of the many tasks it and the engineering team have been conducting since it arrived. And there have been some challenges and surprises too, correct?
Absolutely. I can tell you already the science return from Osiris-Rex has been phenomenal and rewritten a lot of things about what we know about asteroids. I'm going to talk really about three of some of the most interesting results for me. First off, we learned literally about 1 week after getting into orbit that Bennu is what we call an active asteroid. It is ejecting particles from its surface. These particles are coming off at relatively low velocities for the most part. They're actually going into orbit, spiraling around the asteroid, providing some excellent science, allowing us to map out the gravity field of this small body at an unprecedented detail, way beyond what we expected to see. The other thing that we saw right away as we were approaching is that there was some generally dark black surface as expected, but there were these really bright boulders that were shining like beacons to us. And as we trained our science instruments on there and characterized their mineralogy, we were actually able to link them to another asteroid called Vesta, one of the largest asteroids in the solar system, and actually the target of NASA's Dawn spacecraft, which did a phenomenal job characterizing this target. And this just shows you that these asteroids are exchanging pieces back and forth as they collide into each other and shoot their particles off into space.
OREX has processed its next image. Position uncertainty is 0.6 meters.
Wow. And I would say, back to the science, the final result that really is important from this mission is we did expect this asteroid to look sandy and beach-like. And that was based on the thermal properties as determined from telescopic observations from Earth. And we got there and we used the Otis and our OVIR spectrometer to map and produce a thermal inertia characterization of the entire surface. And everything turned itself upside down based on our models. The areas that we thought would be beach-like based on thermal properties turned out to be the largest boulders on the asteroid's surface. And the more fine-grained regions turned out to have what we call this higher thermal inertia, completely opposite of everything we expected, propagating a lot of great science as a result.
And so when you look